Good afternoon, students. Today I will continue some important questions and numericals regarding the ray optics. Afterwards, I will discuss the next part of the ray optics. Okay, so let us continue. So, the first question is that a glass of refractive index 1.5 is placed in a liquid. What must be the refractive index of the liquid in order to make the lens disappear? Okay. So, therefore, it is the refractive index of what? It is the refractive index of glass lens, right? And this glass lens is placed in a liquid. Suppose this is the liquid, a glass lens is here, which have a refractive index 1.5. My question is, what will be the refractive index of this liquid so that the glass lens will disappear inside the liquid? That is, we cannot distinguish the glass lens that is present in the liquid, right? So, whatever we know that if the two medium have the same refractive index, then there will be no refraction at all, right? So, to make the glass lens disappear, we make sure that the refractive index of the liquid should be 1.5. So, the answer will be 1.5. Okay. Next question. What will be the next question? Next question is a numerical. A converging lens of refractive index. So, a converging lens is there. Please don't worry. I will provide you the question and with the answer of these questions which I am discussing. Okay. Converging lens, it has a refractive index of 1.5, right? And it is kept in a liquid medium of the same refractive index. Now, what will be the focal length of the lens in this medium? So, you need to find out the focal length of this converging lens. Okay. So, what will be the answer? The answer is like that. The lens in the liquid will act like a plain sheet of glass. So, its focal length will be infinity, right? So, how it becomes infinity? Let us see. So, according to the lens maker formula, 1 by f equals to mu minus 1 into 1 by r1 minus 1 by r2. This is the lens maker formula, right? Now, what is instead of this mu, as I am dealing with the two media, so I can replace this as mu 2 by mu 1 minus 1, 1 by r1 minus 1 by r2, right? Now, here what I have said, here I am saying that mu 1 equals to mu 2 because both of have them the same refractive index. So, this part will be 1. So, 1 minus 1 it will be 0. So, therefore, 1 by f should be 0, right? So, it implies that as 1 by f equals to 0, so f equals to 1 by 0 and something by 0 is nothing but the infinity. So, therefore, I can say that the focal length of the lens in the medium should be infinity. Clear? Now, next question. What is the next question? Next question is that how does the power of a convex lens vary if the incident red light is replaced by violet light? Okay. So, according to the lens maker formula, this is basically the lens maker formula. So therefore, according to this Lensmaker formula, we can say that power is nothing but 1 by f, right? So according to this, mu violet, that should be greater than mu red. So it's saying that according to this condition, we say that power of the lens will be increased. Okay. Next question is that how does the angle of minimum deviation of a glass prism vary if the violet light is replaced with the red light? We all know that the answer will be that the wavelength of the red light is much greater than wavelength of the violet, right? So therefore, mu red is less than mu violet. It is less than mu violet. Hence, deviation of red should be less than deviation of violet. So when incident violet light is replaced with the red light, then the angle of minimum deviation of the glass decreases. Okay. So this is some sort of question. Next question is that how does the angle of minimum deviation of a glass prism of refractive index 1.5 change if it is immersed in a liquid of refractive index 1.3? So a glass prism is there. For the glass prism, refractive index is basically 1.5, and a liquid in which the glass prism is glass prism is immersed, that is have the refractive index 1.3. So basically what is this a glass prism for? We can write A mu G, that is basically 1.5, and for this A mu W, that is 1.3. Okay. So what is the deviation? So we know that delta equal to mu minus 1 into A, right? So for the deviation in air, that is mu will be mu G by mu A. So therefore that will be 1.5 by 1, that will be 1.5. Now for the prism, I am considering that the glass prism, this angle of prism is 60 degree, right? So therefore, delta will be 1.5 minus 1 into 60 degree, that will be basically 30 degree, right? So this is the deviation of air, deviation in air, right? Now what will be the deviation in water? Deviation in for the water, mu will be basically mu G by mu water, that will be 1.5 by 1.3, which is nothing but 1.15. So therefore delta will be basically 1.15 minus 1 into 60 degree. So if you calculate it, it becomes 9 degree. So for water the deviation will be 9 degree, and for the glass prism the deviation will be 30 degree. Okay. So now second thing is to set the condition for the phenomena of total internal reflection to occur. So basically, two essential condition for total internal reflection is nothing but light should travel from optically denser to optically rare medium. First travel to from denser to rare, and the next is that the angle of incidence of the denser medium, angle of incidence, that is I, must be greater than the IC, that is the critical angle. So these are sort of questions which you may face. Okay. So today I am ending this video. In the next video you will learn, or I will discuss the I think up to the spherical mirror refraction I have completed. So I will start the magnification of the spherical mirror. Okay. Thank you.